Good morning, everyone. My name is Neeraj Tiwari. I am from Electronics and Communication Department, TIT Bhopal. Today, I am going to take lecture on comparator, which is from analog circuit. So, what is the definition of comparator? A comparator, as the name implies, a comparator compares a signal voltage on one input of an op-amp with a known difference voltage on the other input of op-amp. In another word, we can say basically a comparator compares the two values given in one input and second input. So one input and second input. The one input is applied. You have to which may be a time varying signal, and another input may be it's a reference voltage. And whatever output you are taken by the comparator is represented by V naught here. V naught, as you can see here, it's a V naught. V naught is the output of comparator. So what is the concept behind comparator is, I would say it's a principle. What is the principle? Basically, as we know that comparator circuit is looking like a open loop configuration. So open loop configuration. So what is the advantages of open loop configuration? Is open loop configuration has a high gain. That means it has a basically a voltage which can vary from high voltage to low voltage. So high voltage we have refer here plus V saturation, which is to be a VCC, and low output voltage we have refer here is as a minus saturation voltage, which may be a minus of VCC. So that is the concept behind a comparator. And so what about basic comparator? As I told you, the basic comparator, the two types of comparator we can see. First one is a non-inverting comparator, and second one is inverting comparator. If you are applying time varying signal at the non-inverting comparator, then it is called to be a non-inverting comparator. If you are applying time varying signal at the inverting input terminal, then it is said to be a inverting comparator. And output goes to plus B saturation to minus B saturation. As shown in figure, you can see in this picture, basically, this is a simple looking like a op-amp circuit. In this op-amp circuit, this is the minus sign, this is the inverting terminal, and this is the positive sign, this is non-inverting terminal. And here you can see reference voltage we have taken in non-inverting terminal, and time varying signal we have taken in inverting signal. So output, what will be output here? Output will be which would be vary from plus V sat to minus sat. So this will exactly looking like that. So here you can see what input we have taken here. It's a sinusoidal signal. B input we have taken, and reference voltage which are we have taken in non-inverting terminal, which is shown by the red line, and time varying signal which we have which is shown here by the blue line. And we are getting the output which is by the green line. You can say the output, you can clearly see here output varies totally on plus B set to minus B set, plus B set to minus B set. So it's so this is the kind of pulse we are getting in terms of output of comparator voltage. So what is the basic formula you have to keep in mind? We will get an output from comparator if time varying signal is greater than reference voltage, then you will get an output minus of saturation voltage. And if you have time varying signal is less than reference voltage, then you will get a positive saturation voltage. So this is the basic circuit of non-inverting comparator. I'm showing you a non-inverting comparator here, which is generally looking like that. Why I'm saying it's a non-inverting comparator? Because we have applied time varying input signal into non-inverting comparator. So that's why I am saying it's a non-inverting comparator circuit. And here you can see the reference voltage we have applied in an inverting input terminal, and the two diodes D1 and D2 are added here because these are the diodes. Basically, these diode treated as a protection diode because these diode protects the excessive voltage from the reference voltage, and and uh, this diode uh, protect from the excessive voltage of an op-amp. So, and why R1 is added here? R1 is basically added with the time varying series with time varying signal, which will reduce the offset voltage, of the circuit. Now why R is added here? What is the importance of this R? This resistance will limit the flow of current which is passing through the diode, and output we are getting from this terminal and load are connected. This is the RN represented by RN. So that is what that is what is written here, what I explained to you. And as we already know that B, if B in is applied in inverting or non-inverting, and according to you have to say if you applied B in the non-inverting, then it's said to be a non-inverting comparator. If you applied B in is a negative, then it's said to be a inverting comparator. And as we know that if the output of comparator goes to positive saturation to negative saturation. And when the value of input voltage V in lesser than reference voltage and output goes to negative saturation, what I already told you in earlier in the class. So all the things are same. Output voltages V not changes from positive saturation to negative saturation voltage. And one thing more here, now comparator can also be called as a voltage level detector, because if you fix the voltage at the reference voltage, then you can detect the voltage level at the input voltage can be detected from the input side. So that's why it is called it can also be called as a voltage level detector. The diode D1 and D2 are added. The same I told you. It's a protection of op-amp from the due to increase the point input voltage, excessive voltage from the reference voltage. Now the same thing I told you, R1 about an R which is added in the circuit. Now if we look at the output of the comparator, first of all, we have to notice here it's the input voltage, and input voltage we have taken as a sinusoidal signal. It's a sinusoidal V input taken as a sinusoidal signal. You can see here it's varying with time. This voltage, this waveform is varies with time. And this diagram we have taken for the when the V reference means reference voltage is positive. When we have taken reference voltage is positive, in that case, here you can see reference voltage we have taken positive, as you can see dashed line represented as a reference voltage, dashed line represented as a reference voltage. So what output you will get here? See clearly, you can see, as we know that output goes plus V sat to minus sat, plus positive saturation to minus saturation. So output goes from minus saturation to plus saturation. This is what you can see here. And finally, you can see here it's a top of the wave. You can see waveform, top of the waveform. You can see here and here. Clearly you can see input voltage, that means time varying signal, is greater than reference voltage. And here you can see in the downside, you can see here you can see clearly, you can see here the minimum time varying signal is less than a reference voltage. So So this is the diagram in case of when voltage reference is a positive. And if we talk about this one, in this diagram we can clearly see, actually this diagram has taken for the case of when the reference voltage is negative. So clearly you can see the reference voltage is negative here. It's a negative voltage is taken here. Now if you draw the output diagram, so as you know that output changes from plus B set to minus B set, and this type of waveform you will get in case of when you have negative reference voltage. So so what is so here what you can see here, uh, clearly you can see here the time varying signal is greater than reference voltage. In both the plot you can see time varying signal is greater than reference voltage, and downside you can see when the time varying signal is less than to reference voltage. So this is all about comparator waveform. And now the application. So what is the applications of comparators are basically, comparators are used in the device which used in the device such as relaxation oscillator, analog to digital converter, and it can also be used as a device which devices that measure to analog signals. So this is all about comparator. Okay, thank you, class.